Hello and welcome to lesson 1 of week 5. In this lesson, we are going to discuss object-oriented programming in JavaScript. My name is Mildred. Now in JavaScript, object-oriented programming concept is not like we have in other languages, but we have the concept of classes that was introduced in ES6. We looked in the previous week's lesson how we create an object, and object-oriented programming in JavaScript is just a paradigm that organizes the object into self-contained units that combines both the data, which we call properties, and then behaviors, which we call methods. So in JavaScript, it is prototype based. And when we say prototype based, we mean that the object can inherit from other objects through prototypes. Let's review what an object is. We, in previous week's lesson, looked at how to create an object using an object literal. So we can say constant person, then we have name value pairs. Let's say the name of this person is John, then we have the age is 30. Then we have let's create a method here. Let's say greet, and this greet is going to log to the console.log. Let's use this ticks to make it easy. Hello, my name is $this dot, we put this in curly brace, this dot name. Okay, so we did this in previous week's lesson. If you go back to your lesson 3 of week 3, you can refresh how we created objects and how we work on objects. So this is the way we create an object using an object literal, and we can call this, let's say we want to have the greet function, person dot greet, like this, and this will output to the console, hello, my name is John, when we go there like that. So this is an object. We want to look at how we can make this even better and for modern programming, where we create an object and we're creating this as a class using the concept of object-oriented programming, and then we can now create objects from this class. So in other words, a class is a blueprint from which an object is created, and so we want to create that blueprint that will allow developers to have one blueprint and make it easy to create several objects of the same blueprint. So when we talk about object-oriented programming, you want to think about it like you have an empty form and you distribute the forms, maybe like a questionnaire for people to fill in. The blank form is a class, the filled out form is the object, because the blank form holds no data, just a prompt for people to put in information. Now, the information will vary from one person to another, and then they become objects. So once the form is blank, it is a class. When the form is filled out, it is an object. Alright, so you're going to be collecting several objects from the same class, which is the blueprint. So it's asking the same question. The answers are different. The different answers are the objects. Now let's create a class in JavaScript. We create a class using the class keyword like this, and then a name for the class. By convention, you want to start a class name with uppercase like this. So we'll say class person like this. We want to now define the properties, which is going to be the data, and we use constructor like this, and then in a pair of parentheses, let's say this person has a name and age like we did previously, and we want to create this constructor name age, and we want to define what name is and what age is. We say this refers to the class itself. Alright, so this dot name is equal to name. So when the user, or when an object of this class is created, the name that is supplied is going to be the name, and the age that is supplied is going to be the age. So this dot age is equal to age. Now we want to have the method now. That's that function greet that we had previously in the object literal, and when this method is called, we want it to log to the console. So we'll say console.log, and let's put back ticks here and say hi, I am, and in a pair of parentheses, this dot name, and I am this dot age years old. Okay, so when you do this and you call this method, it's going to print this out. Alright, so how do we instantiate this class? When we say instantiate, it means we're creating an object from this class. Now this is a blueprint. We don't have hard printed data here. We're going to have the data by creating an object, and that object is going to hold all of the data. So we create an object by, let's use the const keyword, and now we want to say person 1. Now person 1 will now store information from person 1. So this is now the blueprint. We're creating this from it. So it's like you're having a whole blueprint or an architectural work plan for an estate. You have exactly the same kind of house, different numbers, different units from the same blueprint. Alright, so we say equal to new person, and then the name we supplied, let's supply John, and we'll supply the age date. So you see the constructor here, name age, is what we'll supply here when we instantiate the class. Alright, and then we can create another person. Person 2 is equal to new person, and let's say this is Alice, and Alice is 28. Let's do this. Alright, so now we have the name and the age. So when we call the function greet, let's say person1.greet, and then we have person2.greet. Now, one confusion between what a function is and what a method is that if a method is always within a class or within this definition when we define an object like this. All right, so this is the method we call this. When I come to my console, I'll say, hi, I'm John, I am 30 years old, I'm Alice, and I am 28 years old. So you can see how we have two different persons created from one blueprint. And so when you have your front end developed and you are collecting information that is filled out in the front end, you can use class like this to pass in this information, process it, and then maybe now validate this information, and it's now time to send this information to the back end. All right, so we know that before classes we use constructors to create functions, but now we use a class, and then the concept of objects comes in. When we do object-oriented programming, there is this concept we call inheritance, and when you talk about inheritance, it just allows one class or an object to use the properties and method of another class. These are properties. We call all of these properties, we call all of this method. Okay, whatever we have like a function here is a method. Anything we have here that we collect values from the user is called a property. All right, so a property is like something everybody has, but the value is different for everybody. Everybody has a name, the values are different. The date of birth, everybody has a fingerprint, the values are different. So we use that constructor to write the name of the properties. Okay, and the methods are like the functions within a class. All right, inheritance will now allow us to use the properties and methods from one class in another class. So it's like where we have a parent and the children inherit certain characteristics from the parent. All right, so that class that inherits from another class is a child class, and the class that has all of the properties and methods that is inherited is the parent class. Let's do an example with let's use a different class so we can have a wide range of examples. So we have class animal, and let's say we want this animal to just have a name. So we use a constructor, and then we have name, and in a pair of curly braces we'll say this dot name is equal to name. Now we want to have a method here. Let's call this speak, and we want to define the sound that the animal makes. So here we'll say console.log. We want to define this by saying this. Let's use this and say this dot name makes a sound. We'll say this dot name makes a sound. Now this is the parent class we created. We just want to create like a method here, speak, and we supply the name of the animal and it would say the sound that it makes. But we want to inherit. Let's create a separate class now for a specific animal. In JavaScript, we use the extends keyword to inherit from a class. So we'll say class dog extends animal. So when you use extend here, you are saying this dog is going to inherit everything in the animal class. That's what it means. So class dog extends animal, and you define the constructor now. Now this constructor function, we're getting properties, name, and maybe we want, you can have anything you want, an exhaustive list of properties you want. So if you are collecting information from the front end, maybe a form is filled, all of those form values can be properties here. All right, so let's say we just want breed here. So the constructor, we want the name and the breed, and then you use the super keyword now to inherit a definition of name from the parent class there. So when you use super in a pair of parentheses, we're getting name, and so we're not going to redefine name to say this dot name equal to name, but then we want to define breed because breed does not exist in the parent class. So we say this dot breed is equal to breed like this. Now we want to define the speak here. We already have the speak method here, but we want to, since we've inherited the name from parent class using super, we will just say let's just log this to the console, something similar, but we want to put the sound that it makes. So we want to say this dot name, and then let's say it backs like that. So we change the implementation here, like we're using the speak, but we change it here to say the dog backs, something like that. All right, so let's run this and let's see how it works. Let's try to do an example of this. We want to create an object of the class, so we'll say constant, let's say dog1. So dog1 is equal to, you always create an object using the new keyword and then the name of the class. Now dog already inherited from the animal class, so everything that the animal class has is exposed to the dog class. So it's equal to new dog, and let's say the dog name is body, and let's say the dog breed is, let's say golden retriever, like this. So let's say it's golden retriever, and let's say we call this dog.speak. Since we have this to say the dog backs, so it should print out body backs or something like that. All right, so we want to check if this dog1 that we have here is an instance of the dog class. We'll also check if it's an instance of the animal class, and you should get true for both cases. So you can use its instance of if you are trying to check something. So let's say console.log dog1 is instance of dog. We should get true here, and we should get true also if it's an instance of animal, right? Because we inherited from there. So let's try this. this. We should get body back true here when we refresh our page and we see that there. Okay, so that's the concept of inheritance. You use the extend keyword and you use the super to inherit a property, or when you want to inherit the method. So here we re-implemented the method here to say this dog barks. Okay? We have another concept of object-oriented programming. Take note that the concepts have the same definition across programming language. JavaScript is just not as fully into object-oriented programming as other languages, but the concept is easier in JavaScript. We have encapsulation, which just means you keep something private to encapsulate, keeping something private, and you only expose what is necessary. In JavaScript, we use the pound sign, the number sign like this, to indicate a private field. Okay? So let's try to create something that encapsulation will make sense. Let's say I'm working on a banking app, for instance, and we want to create a class that will accept maybe a deposit amount and then displays the total amount of account balance or something like that. So let's say class, let's call this bank account. Okay, and then we want to get a private data. So the property we want to define is private, like the balance. We want to keep this data private and we want to only expose what is necessary. So let's say the balance will start at 0. Okay, now we want to create a method here that will deposit money into this account. So let's say deposit, let's deposit amount here, and amount is going to be equal to amount. So we'll say amount. So let's say this dot. Now we want to get the deposit amount is going to be this dot. Let's say balance plus equal amount. Let's do that like this. All right. So now we are getting the balance to be equal to whatever the balance was plus the amount that is deposited here. All right. And let's say we want to get a method that will get the balance. So we'll say get balance like this, and this method should now expose what is necessary for us, right? So we'll return this dot, keep using the number sign for a private property like this. Let's try this out. This is just a skeletal example. It doesn't go into the core details, but we'll have labs that will teach us how to do this in more details. So let's say we have constant. Let's call this account 1 is equal to new bank account. Okay, so we are opening a new account for somebody. Or let's say constant. Let's put the person's name constant. Let's say Jane Doe. Let's just write it J Doe like this. It's equal to new balance. Now we want to deposit into the account, so we say Jane Doe dot deposit, because we use this deposit method here and want to put the amount here 1000 for instance, and then we want to log the account balance, so we say console.log Jane-Doe.get balance. So now it should output 1000, or let's say the minimum balance to open is 20, so we'll get 1020. I want you to see this very well. Now when we do this and we go to our console, we have 1020 as the account balance. So you can let your imagination run wild and see how you can implement a class that you can use to work with a bank account, where you can set the deposit. You can create setters and getters as much as you want and do different functions, where you can have a method that can get the name of the account holder. You can have a constructor that has name and other things, just like a proper bank account. Explore with that. But I want to show you something. This is a private field and we want to see the importance of this private field. We use this symbol to ensure that this data is kept private and is only going to expose the things that are necessary. So if we have other properties, we'll list them without the pound sign. Now, assuming we say console.log get Jane-Doe.balance, let's say for instance, we want to get the balance. Now, when we do this, we're going to get undefined because there is no balance. So if we put a pound sign, it is going to restrict us from getting the balance, because it will tell you that this is that you cannot, private field must be declared in an enclosing class. So you cannot use this outside of that. Assuming this was not private, for instance, let's say this were not private, and you say balance, then you can just get it directly because you did not enclose that. So you can see that. So we keep data private and expose what is necessary with encapsulation. Encapsulation uses the pound sign to keep data private. JavaScript. So we have the pound symbol like this to have the enclosure base. There is another concept of object-oriented programming that you hear of a lot in different programming languages. In JavaScript, polymorphism is when we have a method with the same name but it will behave differently when it is called, or based on the object that is calling them. So polymorphism just means many form, right? It's the same definition in all languages. Let's think of how we can implement this in an example that will make sense. Let's say I'm building like like an app, maybe a scientific calculator or an app that we can use to do complex mathematics, for instance. Let's say I want to create a class and I'll call this class shape. Now I want to implement a method within this class. So let's say the method is area. Now if we have a triangle, the area for a triangle, the formula for the area for the triangle is going to be different from the formula for the area of a rectangle of a square. So this is going to be an example of a method that's called area that will behave differently depending on the shape. So here we're going to illustrate both inheritance and polymorphism at the same time. So let's say we want to create a class called circle, and this circle will inherit. So we'll say extend shape, we inherit from the shape class. Now it's going to take parameter, so the property of this is going to be the radius, because we know that for a circle, the area of a circle is pi times radius square. So we'll say constructor. So you always use constructor to get your properties like this. So radius, and what is radius? We'll say this dot radius is equal to radius. But first of all, we want to inherit this method. When you want to inherit or you want to just inherit everything, all the methods, like you see our previous example, we did super, and then in the pair of parentheses we specified what we wanted to inherit. We inherited just the name, but now we want to inherit everything, so we'll just put super without anything in the parentheses. Now we want to define the radius, so we'll say this dot radius is equal to radius. Now we have done this, and we want to define the area for this circle. So we'll say area will now be, let's return. We know that we have pi in the math module, so we'll say math.pi like this. There's a property in the math module here, times this dot radius, and we know that we do exponentiation with double asterisk, so raised to the power of 2 like this. So this is what we want to return for this area. We have another class called square, for instance. This square is still going to inherit from the shape class. Right now we want to get the sides. For a square is the sides that we are getting. We are going to have side raised to the power of 2, right? A side square, that is the formula for the area of a square. So now we're implementing it differently. So while we'll take this, let me just copy this, and we're going to change the definition here to be fast. So the constructor here, we are only getting the side. We are going to use super to get all of this, and then we'll say this dot side equal to side, and then the area now is going to return this dot side raised to the power of 2, because that's the formula like this. So we've gotten that for the square. So you can see how we use polymorphism here, where this area is taking different forms in the different classes that inherit from parent class. So that is called polymorphism. When I try to use this and I say let's create a shape, constant shape is equal to, let's say constant shape 1 is equal to new. So we're going to be getting the circle first. So let's say equal to new circle. So I'll get shape 1, and I want to create an object of the circle class. It's equal to new circle, but I can do this as a list like this when I call this. Let me do this and I'll explain. It's equal to new circle, and I want to get the radius here, because here I'm supposed to pass in a radius to the constructor, and I want to instantiate the square also, and I want to pass in the side for the square 4. So I want to get the circle whose radius is 5 and the square that the radius is 4. So now I can just log this to the console. Let's say shape 1 dot, we did this in last week's lesson, so for each method. So for each, let's say for each shape, we want to log to the console.log, we'll say shape 1 dot area. So I'm doing both of them at the same time. I can get shape 1, do only circle, then do another shape 2, only square. I did it as a list, then loop through the list to now display this to the console. Alright, so we have the area of a circle whose radius is 5, and then the area of a square whose side is 4. 4 times 4 16, radius pi times r times r. So we can do this. This is the same thing as saying shape 1 is equal to new circle, console.log shape 1 dot area. Then we have shape 2 is equal to new square, and let's say we want 4, and then we'll do console.log shape 2 dot area. So you see how the same thing I did with the for each method is the same thing I'm doing here now, and we'll get the same thing here because it's the same. So I just use a list there, then loop through the list and do both together. There is another concept of object-oriented programming we call abstraction, and all of these concepts exist across programming languages that has an object-oriented programming method. We use abstraction where we want to hide complex details and show only essential features. Now, encapsulation and abstraction can get you confused. When you talk about encapsulation, you are keeping data private, but abstraction is not keeping data private, but just hides the complex details and then shows you essential features. Because JavaScript does not have any inbuilt abstract classes, we can simulate them, and let's do an example. One way we can choose abstraction is when we do like our dog example from the animal class, or let's use something different. Let's say we want to do a vehicle, so we'll now specify the type of car. So let's say class vehicle like this, and we want to get the constructor. Now this constructor method, we don't want to pass in any argument, we'll just leave it blank, and we want to say if this dot structure is equal to vehicle, we want to throw an error and say abstract classes cannot be instantiated directly. So we're just trying to simulate what an abstract class does. You can't instantiate it directly, you can't create an object from this class directly. So we're trying to do this in the constructor to create a conditional statement that will make us achieve this. So say if this is equal to vehicle, that's the name of the class, we want to stop it from being instantiated. So let's just use throw new error, and we want to throw the error abstract class cannot be instantiated direct like this. So we are trying to simulate abstract class. Now we have done this and we want to create a method here. Let's say move, for instance. We want to throw an error that this move method must be implemented. So let's say throw new error method move must be implemented. All right, so what we are doing here is we're just trying to simulate an abstract class. So abstraction is just trying to hide complex details, which is what we are doing, but we'll show only the essential features. Now because we have done this, we want to create a class that will inherit from the vehicle class. Let's say for instance, let's have class, let's say bike, and inheritance use extends vehicle. We now want to implement the move method, and we'll say console.log, let's just write anything, bike is moving or something like this. So say the bike is moving like this, and we want to now create an object of the bike class. So we say constant bike is equal to new bike. When we say bike.move, we should get the output the bike is moving. All right, so now you see how we instantiate a class, create an object that does not have any arguments to supply, because the constructor here has nothing to give. We just use this constructor to stop a direct instantiation of the vehicle class. Okay, so it's hiding all of this and it's allowing us to inherit the method from this class vehicle. So when I come here and I refresh, the bike is moving is what we see there. So we can have more complex examples. You can think about this in complex ways. Think about a scenario where this will make more sense than the scenario that I have given here. I'm trying to think about a real world example that will make this abstraction necessary in JavaScript. So while we don't have any inbuilt abstract classes, this is how we simulate one in JavaScript if you want to simulate one. Now every JavaScript object has an internal link to another object, and that other object is called its prototype. Because it has the link to its prototype, it forms a prototype chain which is used for the inheritance that we see. Let's go back to our previous example about an animal. Let's create an object called animal this time. Let's say constant animal, and this animal, let's say animal is equal to, we're creating an object now. Let's say animal eats, and let's say this is true. So we want to create an object to implement this. We want to simulate or try to use the prototype chain to look at the prototype here. So let's say constant dog, for instance. So we're not creating a class here, we're just trying to look at prototype. So the object dot now create, in the pair of parentheses we are using animal, so we're calling that variable animal, or that object animal that we created here. So now we'll say dog dot backs is equal to true. So we're adding a new property to this constant dog that we have created. Now it inherited the eat from this object animal. All right, so when we say that the object has an internal link to other objects called its prototype, this is what we mean. Even though we did not use a class and we did not inherit, but because I use object.create and then in the pair of parentheses the object animal, it already creates that prototype chain. So let's log to the console for you to see. So say console.log, let's say dog.eat. So you see that this already inherited because it has access to, or it has a link, an internal link to this object, to its prototype. All right, so now when I use it, even though you see that there was no inheritance and this is not object-oriented programming, you see that we will be able to get it is equal to true here because we used that. All right. And if you want to test the other one and say dog.back, this is its own property. So this one is inherited from the animal. The it is inherited from the animal class and its own property. Console.log will now log dog.backs. All right. So this one, it's its own property, so it will still be true. All right. But if I want to look at, if I want to say if this object is a prototype of, if the dog is a prototype of the animal, we should get true. So let's say, for instance, I'll say console.log object.get prototype of, I think that's what it is, object.get prototype of, I want to get prototype of dog equal to animal. So we should get true here because dog is a prototype of animal. True, right? So we have seen what it is, and we can add methods to the prototype. So for instance, we want to add a method to this prototype, so we can say animal.walk. This is equal to, let's make this a function, and we are going to log to the console animal walks. Just something simple. All right. So when I put dog.walk, it should print animal walks as an inherited method from the animal prototype there. So see animal walks there. All right. So if you want to check the property ownership, like now we want to see which property is owned by the dog object and which is owned by the animal object. So we can say console.log, let's say, I think we'll put the name of the object. Sorry, let me change this back. I will say console.log, and I will say dog.has own property. Now this it, dog does not have the it property, so let's try it. Has own property, it, and this will return false because the it is the property of the animal object but not for the dog, so you get false. So that's how you will see that it's false because it's an inherited property. So in summary, we say an object is a collection of data and methods. We also said that the class is a blueprint for creating objects. We initialize object properties using the constructor. We inherit from one class to another in a concept called inheritance. We use the extends keyword in JavaScript. Encapsulation will restrict direct access to data, like we saw in the account balance example. We said polymorphism is when we have the same method has different behaviors in different classes, like when we did the shape and we calculated the area for a circle and a square. We have abstraction, which hides the details and show essential features, and we try to simulate an abstract class pattern even though JavaScript doesn't have an inbuilt abstraction in a class. And then we looked at prototype and look at how the object inheritance mechanism works using the object.create. Now, why is object-oriented programming important? Because it will allow us to reuse code. And what we see, we can reuse code through inheritance. We can organize and structure our code better. We can easily maintain and debug code, and then we can actually model real-world example even faster. So this is where we end this lesson. In the next lesson, we are going to look at events in JavaScript. Thank you, and see you in the next lesson.